Good evening, class. Today we're going to go over those questions that were assigned last week, and let's see what we got. Okay, let's start with number one. So if you would take out your question sheet or pull it up on your computer, the question was, how many BTUs to raise the temperature of water? And there were three problems. Before we go there, let's take a look over here on the board. Okay, BTU, review. It's a British thermal unit. It's the amount of heat to raise 1 pound of water 1 degree Fahrenheit. So it would look like this: 1 times 1 equals 1 BTU. Or if it was 10 degrees, it would be 10 times 10 equals 100. Okay? That's how we do it. The math is very simple. You just got to remember how to do it. Okay, so the first one was 431 pounds, and we're going to heat it up 6 degrees. How many BTUs? Okay. I'll just write down the answer. So this was letter A. Equals 258 BTUs. Like that. Okay, 258. It was 43 times 6. It's 258. Okay, the next one is 71 pounds of water, and we're heating it up 84 degrees. Okay, so it's going from one temperature up 84 degrees, and that looks like 5,964. Okay, and the last one was 650 pounds of water, 30 degrees, and looks like 19.5. Okay. Looks like a little reflection in them right here. At least that's what I'm looking at. If you have any suggestions as far as moving this computer in a little closer, a little more light, let me know. Okay, so that is it on BTUs. Now, just as a reminder, unlike some of the formulas that we don't really get to use much, this one we do. And I believe I mentioned this to both groups, but if you have a boiler, we'll say it's 150,000 BTU boiler. Okay, remember, that's in BTUs, of course. Now, this is also a review. I know we talked about this, but this one is really important because this one you need to know. All right, you definitely talk about this out in the trade. If you do hot water heat, you absolutely need to know how these BTUs system works. All right, this would be, for example, this would be the BTUs to run this for 1 hour. That I don't think we talked about. I don't think I mentioned it. But this number here means the amount of BTUs that boiler needs to run continuously, not on and off, continuously for 1 hour. Okay? 150. So that would be, usually that would be oil or gas. Now there is such a thing as electric furnace. I've only seen one once. Pretty rare, very expensive to operate. But this would be gas or oil to run the boiler. Now the output is how much energy is available for you to use for your heat. Radiant, baseboard, whatever. Uh, and they say it's 135. It's always less. Okay, so the output is going to be less than the input. Now, where's the difference here? Where did this go? I guess some of it obviously goes up the chimney. Some of it heats the boiler room. You have been in a commercial boiler room. I'm sure you didn't forget how hot it is in a commercial boiler room. That's just like lost heat coming off the piping in the boiler. So there is a difference. And I know we talked about this briefly last week, but this here is how much you have for your baseboard or for your radiant heat. Now, this I don't think we mentioned, not this year anyway. My advice to you is if you get into business and you're doing hot water heat, which I'm sure you will be, some of you are going to be doing radiant. There's more and more radiant as time goes by, but I'm looking at my baseboard here at home. The baseboard is still popular. It's still a good source of heat. There's nothing wrong with it. It doesn't look bad. And my guess is it's going to be around for a long time. Plus, there's still a lot out there. And occasionally you'll be adding a room, you'll be cutting through, making an addition or something. So you're going to be working with baseboard for a long while into the future. So let's take a look at this. Now, let's say, with this in mind, and this I did last week, but I don't know how many of you were paying attention. So let's go over this again. If you got 135,000, and you have question mark, how many feet of baseboard can that handle? Okay, now this one you should remember. 1 foot of baseboard, 600 BTUs at 185 degrees Fahrenheit. Now, baseboard usually runs between 180 and 200. Right? That's where most guys set the high limit and the low limit. Right? Where it cuts in and cuts out. Obviously, it makes a little less heat at 180 than it does at 200. Okay, but it's close enough. The baseboard is rated at 185 degrees, 600 BTUs per foot. So a piece of baseboard with copper fin puts out 600 BTUs. Now, one thing I didn't mention is I'm going to put it here. Dummy baseboard. That's baseboard with just a piece of pipe. Like that. Usually three-quarter tubing. You're going to say, well, if it doesn't do anything, what's it for? For those of you who don't do much heat, you use dummy baseboard if you have to get like from one room to another and you've already got enough fin and you got 3 or 4 feet to go. You don't want to go in the basement, especially if it's on a slab. You just want to get into the next room. So you put up all the backing, the baseboard, the plate and everything, back plate and the brackets and so on. And you stop with your fin and then you just put copper tubing and go right through the wall into the next room. That's a dummy. Okay, yes, it does produce a little bit of heat, but we don't count it. Okay, for baseboard heat, dummy is not counted. Okay, that's something new. We hadn't talked about that before. All right, getting back to this here. Let's divide 600 into 135. Okay, we can get rid of the zeros like that, right? And 6 here, so we got 2. 2. Looks like 225 feet. That's quite a bit of baseboard. That will handle just about any house, unless you get into a something really big, some big McMansion. That should be enough. Okay. Now, I'm not going to do it now because it's going to take too much time, but we will talk about toe kick heaters, uh, high capacity baseboard, things like that. All right. Another time. But standard baseboard is this number right here. It's been that number for a long time. Okay. All right, let's move on from BTUs. Number two, if the diameter, these are just straight math. The rest of these are all just math. If the diameter is 8 inches, what is the radius? Okay. In case you didn't see the video, or you got a question, remember, that's the diameter, the distance across the circle. The radius is half that. Okay? So diameter equals 2 times r. Or r equals 1/2 d. Well, let's just leave it like that. There's circumference. Let's change this. Call that a c. That's the distance around the outside of the circle, right? Right here. Okay, I don't want to draw it on top because one thing will be messy. Okay, so the distance around the circle is called the circumference. I'll abbreviate it. Equals the diameter times pi. Pi equals 3.14. I'm sure you all had that back in middle school or high school. Okay, so what do we got here? D is, let's give it a number. Let's say D is going to be 8. That means R equals 4. C equals, I don't know. Let's check it out. All right, so we're going to do D equals over here. Okay, now that was the problem number 2. All right, and that's how we arrived at it. So this here equals 25.12. And this, of course, is all in inches. All right, the best way I always think about this is a piece of smoke pipe. All right, so this would be actually a very big piece of smoke pipe, maybe a big boiler or something commercial. So if you got 8 inches, it's about like that, and you open up the smoke pipe and you measure it from, the piece laying flat, it would be this here, right? I know that you got that little where it clips in, but not counting that, it should come out to 25.12. Okay. I'd like to say, is there any question? But I can't ask you that right now. If you do have a question, make a note of it. And when we go live, ask me. All right, but that's what it looks like. You got your diameter, you got your radius, you got your circumference. Okay? Now, I can't honestly say that you're going to be using this a lot out in the trade, but you should be aware of it. Your license. Let's check out number 3. We have the radius is 9, and what's the diameter going to be? All right, let's take a look. see, that was radius is 9. Okay, so that means you got a diameter right here. D equals 2 times the radius. 18. Okay. Now the circumference would be 18 times 3.14 or pi. Right? That's pi. That's that Greek letter. Right? So what's that going to be? So if you multiply those two together, you come up with 5652. Inches. Right? That's the circumference like this. Again, piece of smoke pipe, very big smoke pipe. Open it up like that, and you would have 5652. That would be quite big. That'd be over 4 feet. Okay, now, if your answers match mine, that's fine. If they don't, let's talk about it, okay? I'm not saying I'd bet my life on these, but I'm pretty sure these are accurate. All right, next one. How many degrees for each of the following? Okay. All right, the first one is a 1/8 bend. And that one is 45. I think everybody probably got that one. It's pretty easy. Way to check yourself, remember, is to divide 8, 360. All right? Drawing a blank here. Hold on a second. Do it the long way. Okay, there we go. 5 times 8 is 40. All right, sorry, did a little brain freeze there. 45 degrees. So whatever number they give you on a test, divide this, the denominator, into 360. And that'll tell you what the answer is. So it will take 8 45s to make a circle. All right, let's move on. Next one, quarter bend. Okay, this one's even easier. And you know how that, I guess you can imagine how that goes. 360 equals 90 degrees. Okay? Elbow, anything. It makes 90 degrees. Now, we say a circle. It could make a square. As long as it goes completely around and backwards started, it's 360 degrees. Okay? Next one. 16th bend. (16) into 360. This one's going to be 22.5. Okay? Half of this. All right, now I think everybody here uses a 22.5. But think about it. If you have a 22.5 in your truck, just one, it's going to kick you off at a 22.5 degree angle. But what's going to straighten you out? Nothing. Another 22.5, unless you want to roll some 45s. You really might not want to do that. Okay, so this here equals 22.5. And the last one is going to be half of this. And I know we talked about it last week, but let's do this one again. Okay, now this one here, some of you have probably, especially anybody with tier one, you probably haven't seen this. It's not a common fitting. I've only seen it myself in copper, not that often. I think I might have purchased it once. It's only got a slight kick to it. That might be even more than what it is. That might be a little more than it really is. It would take 32 of those to go around the circle. It's a lot of fittings. Be a very big circle. Okay, this would be a rare situation where the only fitting that could get you around or by or through something would be a 32nd or 11 and a quarter, and then another 11 and a quarter to straighten you out again. Okay, but there is such a fitting. Now the last two fittings, you don't see them very much either. The first one is a 6th bend. Okay, and a 6th bend is 6 divided into 360, and it's 60 degrees. Now, you guys that have been around a while, this is a PVC fitting too. Again, it might get you through something or around. Now, here's a problem. Everything up to 45 is okay on the horizontal, right? You can go straight, 45 back, 45 back. That's okay. If you go 60 degrees and you use a short turn fitting, you might have a little trouble with the inspector, right? You absolutely can't do a 90, right? You can't do a short turn 90. A 60 is a strange fitting. It's closer to a 45 than it is to a 90. The problem is you think you have a 45. Do I have anybody laughing? I bet some of you guys have seen this happen. You think you got a 45, and it's the last one that you have, and you're nowhere near the supply house, and you put it in. It's like, oh crap, it's 15 degrees too much, right? It's a 60. Now a 90 is 30 degrees more than that, so you can't mistake a 90 for a 45. But a 60 you can. You can screw up and think that's a 45. So be careful, right? Take a close look at it, and you might want to keep a couple of 60s. But again, a 60 will get you going 60 degrees, but you need another 60 to straighten you out. Okay, and the last fitting I want to talk about is a 5th bend. Now, getting back, I'm getting carried away with this thing here. The questions on the take home were 45, 90, 22, and then I dropped down to the 60. I just skipped this here. I added this one in, but I did mention it the other night. And now I'm going to throw in the 5th bend. There is such a thing as a 5th bend. Okay, so how does that work for degrees? I think that's 72, if I remember right. Well, let's try. 5 into 360. $72 degrees. Okay, that looks more like a 90. I don't think you're going to mistake that. You're not going to mistake that for 45. All right, it doesn't look like a 45. This one could fool you. All right, now where do you see these? I've only seen them a few times. Let's say we had a cast iron fitting. Comes down like this, and it goes about like that. Okay, it's clearly not a 90. It kicks down quite a bit, so that's either a 6th or a 5th bend. I do remember seeing those in cast iron. Not often at all, but they're out there. And if you see one, now you know what it probably is. It's either a 5th or a 6th. Okay, let's move on. Uh, we have ounces and pounds. Now this one here is a kind of a gift, but if you're a little rusty on ounces and pounds, let's go over it. Okay, just a refresher. Okay, this is a unit of weight now, right? Not volume. This is weight. So if we have 16 ounces, we have 1 pound. Okay. Now the question was not a very tough one. If you have 32 ounces, equals how many pounds? Okay, divide 32 by 16, and you get 2. So the answer is 2 pounds. Now, if it was 320 ounces, okay, it'd be 320 divided by 16, and this would be 20 pounds, like that. Okay, just know what you're dividing. Dividing 16 into the ounces that are given. So the answer to the question was 2 pounds. All right, now the second half of number 6. This is question number 6. Is, and I think everybody knows this one. If you have 1 ton, 2,000 pounds. Okay. Again, this is strictly weight, not volume. So a ton is 2,000 pounds. If you have a car, a very lightweight car, a ton. I got an old Volkswagen. I believe it's about 2,000 pounds, or maybe just over that. And the other day, I was talking with a guy who had an Escalade, a big Escalade. I think it was the biggest. I think he said it was a longer one than some. He claimed to weigh 8,000 pounds, which sounds awfully heavy. I would have said more like 6,000. But anyway, that would be, what, 8 divided by 2? 4 tons. All right, so the problem, actually, that was the problem. Okay, let's write it down. 8,000 pounds, and we'll divide that by 2,000, and if you want, you can just get rid of the zeros. Remember that little math trick from school days? 2 into 8, 4 tons. Okay? All right, now, the last problem was inches and feet. Probably might be the easiest problem of all, but it is one of the problems that is covered by the formula sheet. So what we have is 576 inches. And don't forget the symbols for inches and feet. So how do we do this? Okay, now remember, all right, I'm sure most of you got, all of you got this that tried it. Take 576. We're going to divide that by 12. And coming up with 48. 48 feet. Okay. And the last one we have is 237 inches. Now this one here was a kind of a gift because it came out nice and even, 48. This one doesn't. This next one does not. So let's talk about it. You have 237 inches. All right. Divided by 12. What do you got? You got 19.75. Okay, 19.75 inches. Feet. All right. Here's the tricky part. What's 0.75 feet? All right. Put the 19 aside. We'll leave that over here. Let's do the 0.75. Okay. I think everybody's will agree on this. 3/4. Okay. What's 3/4 of a foot? Okay. Nine. Okay. 3/4 of 12 is 9. All right. So what this is, staying with the decimal, 0.75. Okay. Now, if you have any question about this here, we can talk about it. All right. So just to give you an example, if you see this again, 19.75 was the answer. Let's say you see 0.5 equals what? Half a foot equals 6 inches, right? 0.25, that's what? A quarter of a foot, or 3 inches. And we just did up here, we'll do 0.75 equals 9 inches. All right, so you can remember those. I think you probably already can figure that out. Okay, pretty straightforward. Okay. All right. Yeah, we're running actually just about 30 minutes or just a bit over, so I'm not going to start anything new right now. What I'd like to do is to wrap this video up, and I will see you after you get done with the assignment. You both have different assignments from the textbook. I'll see you back in the classroom after you finish those assignments.